Now it's important to note how elasticity evolves on a straight line demand curve or any other demand curve. Meaning that for a specific good in question, the elasticity may change depending on what the price is currently. To illustrate this, let's just think of this product that could have a range of price between 0 and 7, and its quantity demanded could go from 14 to 0. If I were to divide all these numbers by 2, it would be 7, 6, 5, 4, 3, 2, 1. So essentially, it's going in a very linear fashion. If I think about here, price, and here, quantity. Well, if I were to do steps of 2 down here, okay, and here, steps of 1, roughly, I would see here I have a price of 7, 0 units gets consumed, a price of 6, 2 units gets consumed, a price of 5, 4, price of 4, 6, price of 3, 8, price of 2, 10, price of 1, 12, and a price of 0, 14. And if this was drawn really well to scale, this would be a straight line. So a straight line is also a line that we say is linear or straight. Okay, so this is a straight line demand curve. And by looking at this demand curve is not super steep, which we would say this is inelastic. And it's not super flat, which we would say this is elastic. Therefore, it must be close to being intermediate, so unitary elastic. The big thing here to note is that along a straight line demand curve, and we could kind of reproduce this to other goods afterwards, the elasticity actually changes. It's not because it's a straight line that it's going to stay the same throughout. So to illustrate this, we're just going to calculate a few elasticities, and then I invite you guys to calculate the rest. All the answers are in your handouts. So here, if I were to calculate the elasticity of demand between these 2 points, what I need to do is I need to calculate the percentage change in quantity demanded, which will be equal to, let's say I take this point here as my new point, so 12 minus 14 over the average, 13. And then my percentage change in price is going to be 1 minus 0 over 0.5. Okay, and I were to put this one over the other, and I would obtain here, I would obtain 1/13. Okay, so this number here would become 1/13. Okay, so a very small price elasticity demand. If I were to take these 2 numbers instead, I would have percentage change in quantity demanded would be 2 minus 4 divided by my average, 3. And all of this would be divided by my percentage change in price, which would be 6 minus 5 divided by 5.5. And if I were to calculate the elasticity here, I'd obtain elasticity of 11/3. Okay, and if you were to look at all the other ones, if I kind of jump through here, I see 11/3, 9/5, and so on and so forth. So you could see here, I could say this is a small number, and this, as I go this way, I'm going towards 1, so I'm going bigger. And as I move along, I keep on going bigger. My elasticity becomes bigger and bigger. Therefore, the more I'm moving to a higher price, I get to be more responsive. Why would this be the case? Why is this the case? So let's just redraw another demand curve here, and let's try to see why this is the case. Because what I've noticed here is that when my price was low, I said here that I'm unresponsive. So over here I was saying not too responsive, so inelastic is what's going on here. And I said the upper section over here, I said it's much more responsive, therefore elastic here. And the further I went this way, the more responsive I got. How could I see this graphically? Okay. Well, if I think about this here, we're to think about going from, let's say, here point A to point B. Okay. From point A to point B, I would have this situation where I now have a percentage change. I have a certain change in quantity here, and I have a certain change in price here. And if I were to compare this to point C and point D, okay, I can notice something similar. So for a certain change, I have a certain change here as well. And the actual change itself seems to be similar. And it would be if I were to take the same distance, because I'm dealing with a linear demand curve, the same change would be the same. However, the percentage change in terms of its percentage is quite different. If I look at here, going from A to B, I have a very large quantity. Let's say I'm going from 12 to 10. Very large quantity, and I've had a roughly 20% drop in quantity. So from A to B, percentage change in quantity is small, 20%. Because if I compare this to the percentage change in price here, if I go from this price to this price, I've practically doubled. So my percentage change in price is large in this case, and this is for the same kind of change. But if I were to look at over here, I have the same kind of drop in absolute terms, but when I make it relative to the actual percentage, I could see here that my quantity demanded has dropped by maybe half, so percentage change in quantity has been large. But here, my percentage change in price, if I've gone from $6 to $7, it's quite small. So percentage change in price is small. And since price elasticity demand is percentage change in quantity demanded over percentage change in price, well, I could think that if this here is large over something small, this is bigger than this, then I'll have an elasticity demand that's greater than 1. And here, if this is small, where this is large, I'll have an elasticity demand that is smaller than 1. Therefore, I have an inelastic portion. Then here somewhere in the middle, I'll have a unitary elastic demand. And then if I keep going up in price, it's going to become elastic. Why can this be the case? Well, if you think about it, there's certain goods. You think of just about any good. If you change the price in one direction or the other, it's gonna portray these different responsiveness. If you think about beer, you go out to the bar and you're normally used to seeing beer at $5, let's say, for a beer. If the price were to drop to $2.50, you would probably drink a lot more. A 50% drop would maybe lead to a bigger than 50% increase in consumption. You're to drop it down to $1.25, you'd probably drink more, maybe not such a large percentage increase. And if you keep dropping it, when you drop it to 65 cents or to 25 cents, well, you can't say that the increase in consumption in percentage terms will be as large from $5 to $2.50 as from 50 cents to 25 cents. At 50 cents, most people will be drinking a very large amount, so to drop it down to 25 cents will just have a small percentage increase in the quantity sold because there's already a lot at 50 cents. and that 25 cents different won't make a big difference. But going from $5 to $2.50, you might see a big increase in percentage terms of the quantity sold. Okay, so all goods portray this kind of situation here, and this situation here is going to be very important when we try to maximize our total revenue. It's going to be a very important thing to remember when it comes time to deciding what price to set a good at to maximize total revenue.